Hi everyone, welcome to this video. In this video, I'm going to explain you about one of the simplest machine learning technique called KNN algorithm, K-nearest neighbor algorithm. This is Dr. Lily Florence, Professor Department of CSE, Adiman College of Engineering, Husserl. Welcome you again. K-nearest neighbor algorithm. It is one of the very simplest and easy to implement. We can call KNN as a non-parametric supervised machine learning algorithm. So it is coming under supervised learning since the data set we will use here as either a labeled or continuous data set we will use here. And KNN algorithm can be used for classification as well as regression. So if your data set has categorical data, then we can go for classification, or if your data set has continuous data, we can go for regression. The main concept or the technique used in KNN algorithm is distance-based classification. So here we have to find distance between different data points in the data set. So that is nothing but nearest neighbors. So based on the distance, we have to find what are all the nearest points, and using that nearest points, we have to take a decision for classification or regression. So coming to distance-based measures, there are three types of distance-based method can be used here. Euclidean distance measure, Manhattan distance measure, Minkowski distance measure. Any of these three we can use here, but mostly researchers will use the Euclidean distance based classification we will use here. Some of other names we can refer KNN as memory-based reasoning, example-based learning, instance-based learning, lazy learning. Why we are calling these as lazy learning? No, here it will take more time to train and more time for classification. That is why we are using these as lazy learning. See, KNN, if you are applying KNN for classification, what concept, how do you classify a new data set? We are using the majority votes for its neighbor classes. See, two class of data we have here, class A and class B. Suppose you have a new data is in your hand. You have to classify this new data belongs to which class, either class A or class B we have to find. So here we have to fix your K value, that is number of neighbors we are going to consider for this classification. So suppose I had taken only two neighbors I am going to consider to classify this new data or unknown data set. So what are all the data set are very close to this here, these two data points are very close, the distance is very less. So we can say this new data or unknown class may belongs to class B. So this is the concept we are using in KNN classification. So these algorithms I have given for your reference. There are 6 steps we will use. It is very easy to understand, also very easy to implement using Python, or we can use Java programming also. The first step, select the number K of the neighbors. So we have to select how many neighbors we are going to consider for your classification or for prediction. So that is the first step we have to consider. The next one, we have to calculate Euclidean distance of K numbers of neighbors. So Euclidean distance explicitly we have given here is up to your option. You can use any distance measure formula. Using that, you have to find the distance between your unknown label data with your data points. So calculate the distance between the query example and the current example from your data set. Now add the distance and the index of the example to an ordered collection. So distance you have to add in as a separate column in your data set, and you have to assign index for every distances. That's nothing but, in other words, you can say you have to place rank based on the value. We have to put rank for that. After that, the next step, sort the ordered collection of distance in ascending order. So after completing finding the distance and assigning index for all the distance, we have to sort the index in an ascending order. And now pick the first k entries from the sorted collection. This is our data values where we are using to find the classes for unknown label data. So get the labels of the selected k entries. So we have to take the k entries label here. If regression, that is, you have a continuous data, then you have to find mean of the k entries. That will be your output. If you are using classification, then you have to find mode of the class label. That mode is nothing but the majority modes or the maximum class labels repeatedly occur in the k entries. That will be your class label for the new data set. So this is algorithm steps we can implement. Now I will take you to one example. We can see how to implement KNN. Say height, weight, two attributes we have, and one class label here. So since this is a supervised learning, in supervised learning we will use labeled data set. So this is labeled data set. This is the meaning for labeled data set. So height of a person and weight of a person has been given. Based on this, the class label has been given as underweight or normal. So two classes we are using here. Two classes we are using underweight and normal weight here. So this is our data set. Now I have a new data as height is 170 and weight is 57. This person belongs to which class label? So that is our prediction. That is our classification. We have to classify this data set which belongs to either underweight or normal weight. So let us start our algorithm. So the first step, what is our first step? The first step, we have to fix the value of the k. So let us consider that k as 3 we can take. And the second step, we have to find distance between these data points with all our data set values. So the formula we are using here is Euclidean distance formula. That is distance equal to square over x2 minus x1 the whole square plus y2 minus y1 the whole square. So here x2 and y2 is nothing but our data set. That is the new data values. What we are going to find the class, that will be x2 and y2. And x1 and y1 will be our data set values. Now just you apply these values. That is the first one, 170 minus 167 the whole square plus 57 minus 51 the whole square. This is the first value. Similarly, second value, 170 minus 180 minus 182 plus 57 minus 62 the whole square. So like that, we have to find distance between these data points with all the data points. See here the distance we have filled here. As I said, we have to add one more column for distance and rank. Now we have to assign index, as I said, the rank for this data set. And the next we have to sort in ascending order. So all this has been done here. You just look at this graph. We have this red point is nothing but what we have to find the class of the data, and these are all the points already we have class labels. See, we have to consider the nearest neighbors. Based on the nearest neighbor, we can say this new data belongs to which class. That is the aim of or objective of this problem. So just as coming to our algorithm, we have taken k value as 3. So first 3 values let me take. So first 3 class coming under normal class. So the majority is normal. So here a person with height 170 and weight 57 is coming under class normal. So this is the way we can apply our KNN algorithm for classification. Suppose if you want to find a particular person with height and you want to know the weight of a person. So this is a continuous value. So you have to find the distance. You just imagine we are not having this class label and you want to find the weight of a person. So what we can do here, we can apply average value. So first 3 persons weight will be average and you can some 57 point something will come. Exactly you will get the same. So if your problem is classification, you can apply the maximum values. If you are applying the KNN for regression, we can apply average as a statistical method to find the output or to find the result of the problem here. So this is the way we can apply our KNN for either classification and regression. The strength of KNN is, it is very easy to understand. As I said, it's very simple to understand, also very easy to implement. Also, one algorithm can be applied for both classification as well as regression. So that is why for simple problems, we can use KNN here. But the weakness of the algorithm is it takes more time to classify new examples, since here we are not training and anything, just we are, that is why it is non-parametric. Just we are applying the data set into the algorithm directly. So that is why. And another one, choosing K may be tricky. Yes, if you have very less data set, K maybe you can fix as a 3 or 4 or 5. If the data set is very lengthy and large data set we are using, the size of the K should be the largest one. So based on the K only, the classification and regression accuracy you can get here. So when you apply KNN for your data set, you can tune the value of K to improve the accuracy of the classification as well as regression here. So hope you enjoyed in watching this video. Keep learning.